All right, guys, today what I want to do is finish talking about the rest of the material from 4.4, give you time to work on those. Again, I'll kind of split it up. I'll go through a few examples, let you work, and then go through, answer questions, and go through another example or two. All right, so here's the last little bit of material that has to do with working on these rational expressions. Okay, there's two different ways you can approach this. Okay. So I'm going to show you both of those ways really quickly. Okay, I'm going to start by showing you how to solve this by factoring. Okay, this is probably the easier way to do it, but the harder way to understand how it's done. Okay, so if you can understand what I go through, this is probably the more efficient way to solve the problem. Okay, although if you don't follow what I'm doing here, you can always use the second method that I'm going to talk about. Okay, so using the factoring method, what you're going to do, regardless of whether you have rational powers or negatives, okay, you're going to look and see in the numerator, are there any common bases for the exponents that you can remove out of, again, you kind of look to see, most of the time they're going to be two groups, separated by a plus or a minus. In this case, you see I underlined them. I have two groups of factors. Are there any bases that are common between these two factors? The x plus 4, right? So I'm going to take out that common base. Okay, so step one will be remove common factors. And whenever you remove common factors from powers, you're always going to remove the lowest number. Okay, and the lowest number is the number that's located to the left, furthest to the left on a number line. So which of these powers is lower? 1/2 or negative 1/2? Okay, so that's what you're going to remove. You take out your common factor. Okay, whatever the lowest number is, that's your power. So again, you're looking at the lowest number power. Okay. Once you take all the common bases out that you can, so in this case, this is the only common base between these two. The way that I do it, I always set it up this way, or you'll see me do any examples like this. I show the original form of the problem. So the original expression had one group minus another group. Okay. I'm going to show that form here. It just reminds me that I have to put what remains in the same form as what I started with. Okay, so when I look to see what I removed from here, when you remove or divide out a power, what do you do with the exponents, with the powers? When you divide, you do what with the powers? Subtract. Okay, so because what we're doing, factoring means you're dividing it out. So when you divide this out, what that means is we're going to come back, take this power that we removed, and subtract it from what was originally in the power. So minus a negative 1/2, minus a negative 1/2. Okay, so what's going to happen when you subtract a negative?
1.
It's going to add. So what is 1/2 plus 1/2?
1.
So you get, in this first group, you get the quantity x plus 4 to the first, which you don't need to write the power there. I'm just writing it to show. And then in the second group, what's going to happen when you subtract a 1/2 here? You add the opposite. And so what's happening? Now, negative 1/2 plus 1/2 is 0. Anything to the 0 is value of 1. So it's completely removed, right? We removed that whole thing. So what's left in the second group? Just the negative 2x. Okay, the 4x, or the x plus 4, is going to stay. You don't have to write this every single time. If you want to just work in the numerator, you can. But regardless of this, you can simplify what's in our grouping symbols here. So what's x plus 4 minus 2x? 4 minus x, or negative x plus 4. And so if you simplify what's in here, you get x, or the 4 minus x. And let's put this into the form that I'd suggest, which is x is first, standard form, with the leading coefficient It's positive, so what do I want to factor out of this? So if we factor out a negative, we're left with an x minus 4. There's our numerator. In our denominator, we have an x plus 4. But we also have this factor with a negative power. Well, what can I do with this in order to change the power to a positive? Yeah, so let's move this down to the denominator. So it becomes x plus 4 to the 1/2. And now in the denominator, what do you notice? The bases are common. When you multiply two numbers with the same base, what do you do with their powers? So here's a power of 1 and a power of 1/2. So we get an overall base x plus 4 to the, again, think of this as a 2/2. So 2/2 plus 1/2 is 3/2. And so the other way that you can approach this is, instead of factoring out your negative powers, okay, you can move your powers so that they're no longer negative. If we did that, our x plus 4 to the 1/2 stays just as it is, minus, when we look at this group of factors, the 2x is in the numerator, but because this base of x plus 4 has a negative power, we need to move it to the denominator of a fraction. So we can move that down, x plus 4 to the positive 1/2, and that's all over x plus 4. And does everybody see I didn't do anything to here other than change the form? I took that power of negative 1/2, and I moved that whole base to the denominator of this fraction and changed the power back to positive. And now I can just treat it as the complex fractions like we did earlier in this section. So if I look and I combine my numerator into one single fraction, what's my LCD? I need a 1. I need an x plus 4 to the 1/2. Okay? And then I'm going to take my given numerator of the first fraction, x plus 4 to the 1/2, and I'm going to multiply that by the LCD factor that's missing from its denominator. What's missing? It's x plus 4 to the 1/2. Okay? Minus the next fraction's numerator, 2x, times what LCD factor is missing from this fraction's denominator? Nothing. So we can just leave it or treat it as a 1. Again, we're just working with this fraction right now. What happens when we multiply two numbers with the same base? What do you do with the powers? So we're going to add these, x plus 4 to the 1/2 plus 1/2 is 1, minus 2x. Again, if we keep simplifying this, we get the same thing that we did in the other one. Negative x plus 4 is our numerator. X plus 4 to the 1/2 is our denominator. And now we're going to divide by this fraction. We don't have to simplify it any further. But instead of dividing, we're going to treat this multiplying by the reciprocal. So we take this x plus 4 from the numerator, we're going to write it in the denominator. And we're going to move this 1 into the numerator. And so here we get, again, let's say we factor out that negative, x minus 4 all over, and we have this common base in the denominator, x plus 4 to the 1/2 plus 1 is 3/2. Okay. And so you wind up with the exact same thing, okay, only we treated it as a complex fraction here instead of as a factoring problem. 1.
So at the beginning you go ahead and